Hello everyone, this is Team Harambe. This is our presentation for the Wikipedia question generation and answering system. Our team members are Abhineet, Praneeth, Gayatri and Tejas.
Let's get started with the question generation module. To begin with, let us generate some basic questions. These are sentences of the subject predicate form. They have noun phrase verb phrase structure, the subject being the answer to the question. We use named entity recognition to identify the subject entity, and based on the classification, we would form questions of the type who, what, when, where, whose, etc. For example, Harambe was born in Texas. Thus, identify Harambe to be the subject of the sentence and being a person. Form a question who was born in Texas. Whose questions are generated by identifying sentences in the same format but the subject as a possessive noun. We identify this form from the past tree as a POS and create a whose question removing the subject. In this case, the question is whose favorite fruit is apple. For location and time questions, we begin by locating prepositional phrases in the past tree of the sentence. Remove the subtree and based on the preposition, we append the relevant question tag. For example, in this case, a when question can be formed as well as a where question can be formed. For example, when was Harambe born and where was Harambe born? Let us generate some difficult questions. Which questions involve finding a list in the sentence, that is, words having the same POS tag separated by commas. Identify the hyphenon and form a question, Harambe likes to eat which fruits? Why questions? Hunt for words like why, because, since, etc. Then we can modify the noun and form a question like, why did he fail the exam? Or we can form a why question by substitution. For example, his flight was delayed because of what? Moving on to numeric questions. We look for the POS tag CD, which denotes numbers, followed by a metric. For example, Mount Everest is how many feet tall? The corner cases for these questions are dates and addresses. Both of these cases do not fall in the numeric question category, and these questions are not grammatical. Binary questions involve playing around with the main verb. Using a past tree, we find the inverted form of the sentence. Based on this, we then construct the yes-no question. To trick the other answering systems, we use auxiliary inversion, that is, adding a negation before the verb. Thus, our system would not only generate a straightforward question like, did David like Emily? It would also generate, did David not like Emily? Answering system. Given a question, the first step is to identify the type of the question. It may be an informative question like when, why, how, what, who, where, or a yes-no question. For an article and the question, we find the closest 5 potential answers. We define the closeness using Jacquard similarity and cosine similarity. We filter out such sentences, and for every potential answer, we do a deep comparison with the sentence. For example, for a who question, we would look for person. For a when question, we would look for date and time. For a where question, we would search for location. For what, we look for organization. Why question, we look for because. How many is found by looking for a number. We also use the wordnet to do a semantic analysis and match similar sentences. For example, what is the height of Mount Everest is the same as how tall is Mount Everest. Finally, we do subtree matching to be entirely sure about the answer. All the above processes are sorted and the candidate with the maximum score is the most likely answer for the question. As a part of our answering system, we tried to implement a deep learning model as well as a baseline model. Our initial long short-term memory network involved feeding in a Wikipedia article along with the question. The embeddings of the input article and question are combined, and after passing through the dense layer, the answer is computed. A drawback to this approach was we were padding all of the inputs to the maximum input sentence length. As the number of sentences grew, the accuracy fell and the training time failed to converge. We came up with an alternative approach to tackle this. Rather than feeding in verbose and noisy paragraphs, we pre-compute a few candidate answers based on their cosine similarity. Each of these candidate answers are fed into our modified LSTM network with an attention layer. The output for this layer is a softmax dense layer with the probability of it being the answer to the question. Whichever sentence returns the highest probability is considered to be the best matching answer. If none of the answers indicated sufficiently high probability, the answer from the baseline model would be taken into consideration.
You were so big and strong, ever since